Welcome to our first lesson, which is lesson 1.1, where we are going to be graphing quadratic functions in standard form. So this video specifically is going to direct your attention to standard form, and here is the standard form of a quadratic function. In the following videos, we're going to be looking at vertex form as well as intercept form, but today I'd like to focus on graphing quadratic equations in standard form. That's our goal. So the vocabulary that is very important for you to understand are listed right here on the first part of this page. So please fill in the blanks. A quadratic function is a function that can be written in the standard form, and we want to make sure we know that A, B, and C in this form are very, very important. We're going to be utilizing those coefficients. Now, A cannot be equal to 0 when we're talking about this form. So A has to be a negative or positive number, but it cannot be 0. The next thing we need to know is that the graph of a quadratic equation is a parabola. So that's going to take this form, or if it's a negative function, it's going to take this form. So therefore, on any parabola, we have a lowest point or a highest point, and that lowest or highest point is referred to as the vertex. The vertex can be calculated, and we're going to be working on that to get a solution for the vertex, as well as the axis of symmetry. Now the axis of symmetry is going to divide the parabola into mirror images. So we already know that it's a symmetric type shape, so we're going to find that axis of symmetry where we could fold the parabola in half so that it could line up on itself. Now this axis of symmetry does pass through the vertex. So once we know what the axis of symmetry is, we can calculate the vertex, and that is 2 points. That's an x value as well as a y value, because it's either the lowest or the highest point on the parabola. The last statement in this vocabulary section says that for y equals ax squared plus bx plus c, the vertex's y coordinate is the minimum value of the function if a is greater than 0, and it is the maximum value if a is less than 0. So that's just stating that if we have a parabola that looks like this, then a is probably a negative number because it's less than 0. If it looks like this, then a is going to be positive because a would be greater than 0. There are some important things to look at in the box that says key concept. So the parent function of a quadratic function is just this right here. X squared is going to be the parent function. So if we plug lots and lots of values in for x, we would get this curve that's shown in the picture here. The vertex is at 0, 0. So for the parent function, the graph sits right on that origin. That is going to be the lowest point, so that's called a minimum. And the axis of symmetry is really just the y-axis, and we could simply just fold that parabola in half on the y-axis, and that is our axis of symmetry. So a lot of times we're trying to compare a graph that we might be, asked to graph to this parent function. How does the graph change? Does it get skinnier? So in other words, could I look at a graph that looks like this? Maybe it still has the same vertex, but it's skinnier. Or maybe it is a little bit wider, but it still has the same vertex. Okay, so we're going to be looking at not just the parent function of y or f of x equals x squared, but as the equation changes, how does the graph change? Does it get skinnier, wider? Does it shift to the right, or does it shift up? So that's what we're going to be looking at, not just graphing, but also making some comparisons. Alright, let's get down to doing some graphing. So we're going to take a look at this graph, this function actually. They're going to ask us, or they have asked us, to graph this. So to graph it, I want to plug in the values that they've given me for x. So I'm going to plug in -2, -1, 0, 1, and 2 into the function. But before I do that, let's take a look at what the graph should look like. Well, and we see that the a value is -1, so that means to us that we know we're looking for a downward facing curve. It's going to have a maximum point since a is less than 0. And it looks to me like our interception of the y-axis is going to be +2. Our c value is always going to be where the graph crosses the y-axis. So let's get busy plugging in -2. So we have y equals negative, and we're going to square -2, and then we're going to add 2. And that ends up with a -2 result. So let's go ahead and plot that point. That's my first point, and then I'm going to plug in -1. So y equals negative, and we're going to square -1 plus 2, and that result is 1. So I'm going to go ahead and plot that point, which is going to be right here. And for the sake of time on the video here, I'm just going to give you the remaining y values. But, you know, in the practice, I would like you to show your work and get these other points. So at 0, when x is 0, as we already realized, our y-axis would be crossed at +2. Remember, our c value is where the graph is going to hit the y-axis. And then we know for sure that we have a plot here, a point here, and also at 2, -2, because we can see that that y-axis is our axis of symmetry. And so we have points on either side equidistant from our axis of symmetry. And a lot of times I'll ask you to show me your axis of symmetry by indicating it with a dashed line like this. That's not what they asked us to do in this problem, but I just wanted to introduce that idea. So did we plot the points? Yes, we did. Did we draw a smooth curve through the points? Yes, we did. So we already knew that because of our negative a value, we would have this downward facing curve. All right, so let's take a look at example 2. In example 2, we're going to be graphing this function, and it looks to me like this is going to be an upward facing curve with a minimum value, and that's because our a value is positive. So this is going through some different steps. We have to identify the coefficients for the first step, find and plot the vertex for our second step, draw in the axis of symmetry on our graph, and then for step 4, we're going to identify the y-intercept and reflect that point in the axis of symmetry, evaluate the function for when x is equal to 1, and then draw a parabola through the plotted point. So it has a few more steps, but this is going to make it so that we can be a lot more flexible with our graphing. So with this method of graphing doesn't make us do that table of values. So first identify a is going to be 1, that's the number in front of the x squared term. B is -6, that's the number in front of the x term. And then C is going to be 8. And this is also going to be our y-intercept. So 8 is where we're going to have a point for sure. And it doesn't necessarily mean that that's on the axis of symmetry, but we know for sure that the C value is going to be plotted on the y-axis. So step 2, it says find and plot the vertex. So to find the x-coordinate of the vertex, we are going to use this little formula here. So just as a reminder, a vertex is going to have 2 points. It's going to have an x value and it's going to have a y value. So the first thing is we're going to find the x part of the vertex by using -b over 2a. Well, b is already negative, so that means we need to turn it into a positive. So x is going to be 6 over 2 times our a value, which is just 1. So 6 divided by 2 is 3. So we know that the axis of symmetry is going to be x equals 3. I'm going to go ahead and draw that in now. So this is where our mirror image is going to take place. And to find the y-coordinate of the vertex, we're just going to plug in 3 into our graph. Into our function. So y equals 3, because that's our x value, squared, minus 6 times 3 plus 8. So 9 minus 18 plus 8. So that means that the vertex is actually 3, negative 1, because our y value is negative 1. Whoops, equals to negative 1. So let me go ahead and plot that right now. That's going to be right here. 3, negative 1 is the lowest point on this graph. And it looks like we already did step 3, or I did step 3. X is equal to 3 since x was equal to 3 in the vertex. So that dashed line is our axis of symmetry. So we've done that. And then it says identify the y-intercept 0, 8. We did that already because I have that red dot. And reflect that point in the axis of symmetry. So what they're asking us to do is take a look at the distance away from the axis of symmetry that we have our our y-intercept, and go the same distance to the other side of the axis of symmetry. It looks like we're about 3 units from the axis of symmetry, so I need to go 3 units on the other side, and that point right there is equidistant from the axis of symmetry. So 6, 8 is one of my points as well. They also ask us here in step 5 to evaluate the function for x is equal to 1. That just means find a number that's close to, that's kind of close, an x value that's close to where your vertex is, and plug in that value. So I've done that. I've plugged in 1 everywhere there was an x, and my evaluation of that is 3. So another point that I know I can plot is going to be 1, 3. Now the only reason we need these extra points is to help us make our curve look a little bit more round rather than like a V. So this is 2 units away from the axis of symmetry, so I'm going to plot another point over here. And then it says draw a parabola through the plotted points. That's our step 6. So all I have to do now is real carefully, and I am going to put an arrow on the end of these because they continue on. It's hard to make it real smooth and curve-like, but try to do the best you can and try to make it not look like a V. It's challenging, but make an effort, please. And so there's our curve, and it is symmetric. It's a mirror image of itself right through that through the axis of symmetry. So before we get to example 3, I would like to point out that I have some practice problems for you to try. So these practice problems here can be done on that second page that is attached to this note sheet. So please try to graph all of these 5 functions and label the vertex for me, please, and the axis of symmetry. So you can use the table method if you'd like to. Pick some points for x and plug those in, or you can use the x equals negative b over 2a to find your x value of the vertex, and then that result, whatever you get, can be plugged in to find y. So it's up to you how you want to do it. I would just like to see your finished practice problems, please. And then we have one last example here. It says tell whether the function y equals negative 2x squared plus 8x minus 7 has a minimum value or a maximum value, and then find that minimum or that maximum. So basically they're asking us to find the vertex here. So if we look at our a value, this is going to tell us if it's going to be a maximum or a minimum. A is equal to negative 2, and we know that negative 2 is less than 0, so that means then because a is less than 0, we're going to have a maximum point, and our curve is going to be shaped like this. So we've already answered one of their questions. That is a maximum point that it's going to have, and now we need to find that maximum value. And so just use the idea that you're finding the vertex when they're asking you for the minimum or the maximum value. So to find the vertex, I'm going to use my handy formula, negative b over 2a, and in this case b is 8 and a is negative 2. So x is negative 8 over 2 times negative 2, and then we get negative 8 divided by negative 4, so our x value is 2, but that's not all we're looking for. So a vertex has 2 points. It has two values. It has an x value, which we just found, and then it has the y value. So let's plug in 2 into our function to get our y value. So negative 2 times 2 squared, because that's what we just found out what that x is, and 8 times 2 minus 7. And that equals 1. So the maximum value for this graph is going to be when y is 1 and x is 2. And I then would like you to do these last 3 practice on your own problems. Similar to the one that I just did, I'd like you to tell whether it's a minimum or maximum for each function, and then find the minimum or the maximum. And you can ask questions in class. If any part of this video was confusing, you may want to rewind it, or just make a little note to yourself so that you can ask a question when you get to the classroom. Thanks for watching.